The Dead Sea is disappearing, and what scientists just discovered hidden in the geological data is triggering emergency protocols across 3 nations. March 3, 2026 at 6:17 in the morning, local time. Ground-penetrating radar arrays deployed along the western shore returned imaging data that should not exist outside a catastrophe simulation. Within 72 hours, survey teams documented over 340 new subsurface voids that formed in just 90 days. But here is what has geologists in complete disbelief. This is not random erosion. This is a pattern. A pattern that reveals something scientists thought impossible. Emergency response logs tell the story in stark numbers. 14 buildings were condemned in Ein Gedi in a single week. A 200-meter section of Highway 90, the only north-to-south artery connecting Israeli communities along the western shore, collapsed into a void that opened without warning at 4:30 in the afternoon while vehicles were on the road. Resort facilities that hosted tourists 48 hours earlier now sit at the bottom of craters 30 meters deep. But it is what happens in the 96 hours after that radar survey that transforms a chronic geological problem into an accelerating catastrophe. Machine learning systems, analyzing 40 years of satellite imagery, have detected a fundamental acceleration in the collapse mechanism. The sinkholes are not forming randomly. They are following the ancient shoreline. A massive subsurface dissolution front is advancing inland at rates that have doubled in 18 months, eating through salt deposits that have supported the landscape for 10,000 years, and undermining roads, buildings, and critical infrastructure from below with surgical precision. Hebrew University researchers just published data that changes everything we thought we knew about this geological system. Their AI-enhanced analysis expanded the known sinkhole catalog from 3,000 surface features to over 6,400 subsurface voids invisible to the naked eye. Conventional surveys missed them entirely. Hidden within that subsurface data is a discovery that sends chills through every geologist studying the Jordan Rift Valley. The dissolution front is accelerating in sequence, zone by zone, layer by layer. It is carving a corridor of structural failure straight through the foundation of communities, highways, and industrial facilities along both the Israeli and Jordanian shores. Thermal imaging shows something catastrophic happening within that corridor. Freshwater infiltration rates have increased 280% in the last 24 months. The mechanism that creates sinkholes, fresh groundwater dissolving ancient salt deposits beneath the surface, is not slowing as some models predicted. It is feeding on itself. As the Dead Sea drops, more shoreline is exposed. More fresh groundwater reaches salt layers that were protected for millennia. More salt dissolves. More voids form. More ground collapses. The cycle accelerates with each meter the water level falls. The Dead Sea is dropping 1.2 meters per year. That is the fastest sustained decline in recorded history. And here is what that actually means. A geological dissolution engine operating beneath the shores of the lowest point on Earth is consuming the structural foundation of the landscape faster than any scientific model predicted. Not stabilizing, not reaching equilibrium, accelerating. But here is what has scientists across 3 nations in a state of alarm they can no longer contain. The last time dissolution rates approached current levels in geological analog systems, the result was not gradual subsidence. It was catastrophic ground failure across areas measured in square kilometers. The same dissolution chemistry, the same freshwater and salt interaction, the same exponential acceleration curve that precedes sudden large-scale collapse events in evaporite geology worldwide. Scientists are watching identical precursors unfold along 70 kilometers of inhabited shoreline, and the Dead Sea keeps dropping with no intervention capable of reversing the decline. Is the Dead Sea Basin approaching a geological tipping point where chronic sinkhole formation transitions to catastrophic regional ground failure? Or has that transition already begun? As of March 8, 2026, the Geological Survey of Israel maintains its highest ever hazard classification for the western Dead Sea shore. The classification was elevated on February 12 after the Highway 90 collapse and the discovery of 340 new subsurface voids in the quarterly radar survey. Active geological hazard requiring immediate infrastructure assessment and population safety measures. 4 decades of monitoring, and the problem has never been this severe. The numbers tell a story of relentless acceleration. Ground surveys combined with satellite-derived INSAR data document over 6,400 sinkholes and subsurface voids along the Dead Sea's western and southern shores. The formation rate has reached an average of 4 new surface sinkholes per day. That is triple the rate measured in 2015, quadruple the rate from 2008. The exponential curve that scientists warned about for 2 decades is no longer a projection. It is the observed reality. The Dead Sea's surface level now sits at -438 meters below sea level, the lowest surface elevation of any body of water on Earth, and still falling. 1.2 meters of decline per year. The lake has lost approximately 1/3 of its surface area since 1960. Shoreline has retreated by up to 1.5 kilometers in some sections along the southern basin. Where water once covered the surface, exposed salt deposits now sit vulnerable to the fresh water that flows through underground aquifer systems from the Judean hills to the west and the Jordanian plateau to the east. Dr. Gideon Bear, head of the Geological Hazards Division at the Geological Survey of Israel, addressed the acceleration during a press briefing on March 5th. The rate of subsurface void formation we are documenting exceeds every model we have published in the last 20 years. We are in a regime of dissolution that our standard predictive tools were not calibrated for. The salt layer is being consumed from below at rates we did not anticipate reaching until 2040. Compare the current 4 sinkholes per day to the 0.3 sinkholes per day average measured during the 1990s. That is more than a 10-fold acceleration in 3 decades. The ground along the Dead Sea shore is failing faster than at any point in recorded geological observation. Subsurface void dimensions are escalating in parallel with frequency. Voids detected in the 2024 radar surveys averaged 8 meters in diameter and 4 meters in depth. Current surveys reveal voids averaging 14 meters in diameter and 7 meters in depth. Some extend to 30 meters across. The largest void documented in the February 2026 survey spans 47 meters beneath a section of the Ein Gedi Nature Reserve parking facility. The surface above shows no visible indication of the cavity below. The ground looks solid. It is not. Groundwater monitoring wells positioned along the western shore detect the chemical signature of the dissolution process in real time. Chloride concentrations in shallow groundwater have increased 180% since 2018. Sulfate levels have climbed correspondingly. The water emerging from the dissolution zone carries the dissolved remains of salt deposits that accumulated over 10,000 years of evaporation in the Dead Sea basin. The salt is leaving. And when salt leaves, the ground above has nothing to stand on. Seismic monitoring adds another dimension to the data. Microseismic arrays deployed by the Geological Survey detect the sound of underground collapse in real time. Each sinkhole formation event produces a distinctive acoustic signature as salt dissolves, cavities expand, and overlying sediments fail into the void. The arrays record an average of 12 collapse-related microseismic events per day along the western shore. Some days produce over 30. The ground is collapsing continuously at depths invisible from the surface, in a process that produces no warning until the moment the surface itself gives way. The Dead Sea has been dying in slow motion for 6 decades, but the crisis entered a new phase that no one predicted. The Dead Sea surface sits at -395 meters. The lake covers approximately 1,050 square kilometers. The Jordan River delivers 1.3 billion cubic meters of fresh water annually. The system exists in rough hydrological balance. Water enters from rivers and springs. Water leaves through evaporation. The level fluctuates seasonally but remains stable across decades. Then, the diversions begin. Israel completes the national water carrier in 1964, diverting water from the Sea of Galilee for agricultural and municipal use. Jordan constructs the King Abdullah Canal, drawing from the Yarmouk River, a primary Jordan River tributary. Syria builds dams on the same tributaries. Each nation takes what it needs. What each nation takes comes from the same source. By the 1980s, the Jordan River's flow into the Dead Sea has been reduced by over 90%, from 1.3 billion cubic meters to less than 100 million cubic meters. The river that sustained the Dead Sea for geological ages now arrives as a polluted trickle carrying sewage and agricultural runoff. The evaporation continues unchanged. The sun does not negotiate with water policy. The lake begins its descent, minus 400 meters by 1985, minus 410 meters by 1997, minus 420 meters by 2005, minus 430 meters by 2015. Each meter of decline exposes new shoreline. Each meter of exposed shoreline presents fresh salt deposits to groundwater that dissolves them with chemical inevitability. The first sinkholes appear in the early 1980s along the southern shore near the Dead Sea Works mineral extraction facilities. Scientists document them as curiosities. They are localized features of limited significance. The initial formation rate measures a handful per year. The voids are small. The damage is minor. The phenomenon receives academic attention but no emergency response. By the 1990s, formation rates climbed to approximately one sinkhole per week along the western shore. The first infrastructure damage occurs. A date palm plantation near Ein Gedi loses 3 hectares to sudden ground collapse. A section of access road drops into a void 15 meters deep. The phenomenon transitions from academic curiosity to infrastructure concern. The 2000s bring acceleration that begins to alarm the geological community. Sinkhole formation doubles, then doubles again. Entire beaches disappear overnight. The Ein Gedi Spa Resort, once a premier tourist destination drawing visitors from around the world, closes permanently in 2015 after sinkholes consume the surrounding landscape. Pools and buildings that serve tourists for decades sit abandoned at the edges of craters that grow wider each month. During the 2010s, the crisis reaches dimensions that reshape regional planning. Highway 90 requires repeated rerouting as sections of roadbed collapse. Communities along the shore face evacuation decisions. Agricultural operations abandon fields as the ground beneath irrigation systems fails. The geological community publishes increasingly urgent warnings. The political establishment acknowledges the problem, while the water diversions that cause it continue unchanged. 2020 to 2025 brings the data that eliminates any remaining ambiguity about the trajectory. Formation rates accelerate past every published projection. Void sizes increase. The dissolution front advances inland at measurable rates. Infrastructure damage costs exceed $200 million. Then a February 2026 radar survey reveals that the visible sinkholes represent less than half the actual subsurface void inventory. The problem is twice as large as anyone knew. It is growing faster than anyone predicted. The dissolution mechanism is the Dead Sea's geological autopsy performed in real time. The geology beneath the Dead Sea shore consists of layered sediments deposited over thousands of years. At critical depths, typically between 20 and 60 meters below the current surface, lies a layer of rock salt deposited during periods when the Dead Sea and its predecessors evaporated and contracted. This salt layer, called the ZE Limb Formation, extends along much of the western and southern shoreline at varying thicknesses from 5 to over 30 meters. When the Dead Sea surface covered this salt layer, the brine above and the pressurized saline groundwater surrounding it prevented dissolution. The salt was in chemical equilibrium with its environment. Saturated brine does not dissolve salt. The layer was stable for 10,000 years. As the Dead Sea level drops, the protective brine retreats. Fresh groundwater from the Judean hills and the Arava Valley, undersaturated with respect to salt, flows through aquifer systems and reaches the exposed salt layer. The chemistry is immediate and irreversible. Fresh water dissolves salt. The salt layer thins, develops cavities, and eventually creates voids large enough to cause surface collapse. Dr. Eli Raz, a Dead Sea geologist who has studied the phenomenon for over 30 years, describes the process with the precision of someone who has watched it consume the landscape he dedicated his career to understanding. The dissolution operates as a positive feedback system. The more the lake drops, the more salt is exposed. The more salt is exposed, the more fresh water reaches it. The more fresh water dissolves salt, the more the underground structure weakens. There is no equilibrium point. There is no natural stopping mechanism. As long as the Dead Sea continues to decline, the dissolution will continue to accelerate. The freshwater infiltration data confirms the acceleration in mechanical terms. Monitoring wells track the rate at which fresh groundwater reaches the salt layer. Between 2000 and 2018, infiltration rates increased approximately 40% as the Dead Sea's retreat exposed progressively more salt to the aquifer system. Since 2018, the rate has increased an additional 280%. The acceleration is not linear. It is exponential, and the mechanism driving the exponential growth is geometrical. As the shoreline retreats, the area of exposed salt increases not as a line, but as a zone. Each meter of Dead Sea decline does not expose 1 meter of salt. It exposes an area of salt proportional to the topographic profile of the shore. Where the shore slopes gently, a single meter of decline can expose hundreds of meters of lateral salt deposit. The dissolution front advances across this entire area simultaneously. Ground-penetrating radar surveys conducted quarterly since 2019 map the subsurface void inventory with resolution sufficient to detect cavities as small as 1 meter in diameter. The March 2026 survey reveals the current state of the subsurface in data that the Geological survey describes as the most concerning dataset in the program's history. 6,400 identified voids along the western shore alone, an increase of 1,800 from the December 2025 survey. The dissolution front has advanced an average of 85 meters inland since the previous quarterly measurement. In the Ein Gedi sector, the advance reaches 140 meters. At this rate, the front will reach the foundations of buildings and infrastructure currently considered safe within 18 to 36 months.